Hey everyone, we're going to take a look at developing skills for the Alexa voice assistant using TypeScript and Node.js. We're even going to include JavaScript in the mix as well. So a little bit about myself. My name is Nick Raboy. I'm a developer, I'm an author, blogger. I do a whole lot. I will provide links to all of these resources at the end of my presentation. But the important thing that we're going to try to accomplish here is we're going to try to accomplish building a very simple skill for Alexa. So recently, it was brought to my attention that Alexa is still not available in many countries. So I do want to give a mention on what it is, so a little background. So actually, Alexa, of course, is the voice assistant for Amazon products like the Echo, but it's also available for other items as well. So there's a lot of people installing the Alexa voice assistant on Raspberry Pi devices. I think Pebble is using Alexa. So it's really a voice assistant for any kind of technology. It allows you to create skills, which I sometimes refer to as apps. And these skills can do a lot of tasks. They can control devices, they can play music, they can do pretty much anything you can imagine. So here are some of the Amazon Alexa devices. So of course there's the Echo line of being the Echo Tap, Dot, and then the standard Echo, but also the Amazon Fire TV. So I actually own the Echo. I have a few Dots coming as well. They're actually really cool devices. Amazon does have its own skill store. So this is kind of like the Amazon App Store or iTunes or Google Play, where you can go in and you can select skills that will work with your Alexa powered device. So just to be clear, skills are not something that you install to the device. Skills are hosted in the cloud, and what you do actually is you enable skills. So you enable Alexa to be able to use skills that are hosted in the cloud. And we'll get more on that as we go along. So when it comes to planning a skill, you can actually create and host your skill in two different ways. So you can actually use Amazon's AWS Lambda service, or you can self-host it. I personally have a skill that I release that I use on Lambda, and that's going to be the focus of this particular session. If you do use Lambda, you can use Java, Python, or Node.js to design this skill. If you're self-hosting it, you could use any programming language that you want. The cool thing about developing skills for Alexa is you don't need to have an Alexa-powered device to make this possible. Amazon does provide you all of the resources necessary to test your skills in the cloud. You can also test them locally on your machine, which we're going to be demonstrating in this particular session as well. When it comes to developing a skill, we're going to be, of course, using Node.js with TypeScript. But if we break it down, a skill consists of logic, which includes the speech handler, so what happens when certain speech is executed. It includes the use of the Alexa SDK. And then it includes the use of your imagination. So pretty much anything you can think up can become a skill. Anything that would be useful would be better as a voice assistant type technology. And then it also includes speech sample data. So when you develop a skill, you need to provide Amazon sample data on how to use your skill. So for example, say we have these three sample utterances. So sample utterances is the same way of saying sample speech data. But these three utterances accomplish the same task. So you would be asking Alexa to use your skill by whatever you've named it. And you would say to give me the time in location, where location is a placeholder parameter, which can be very dynamic. It's what you speak in, and then your actual skill can determine what to use with that term. But as you can imagine, there's probably 100 or more ways that this particular phrase can be said. What you want to do is you actually want to come up with all of the possible combinations, so that way there are no discrepancies when trying to use your skill. Because if you have too few and Amazon doesn't know how to interpret it, you'll just get an error instead. So when you actually read these skills to Amazon, what it does is it parses it into a JSON object like this. So it'll recognize that particular phrase. It'll say, hey, this is part of the time intent, where intents are actually, you're going to be creating intent handlers. So you would assign intents per every phrase or a group of phrases. it would recognize that there's a location placeholder, and then it would recognize that, hey, maybe we said San Francisco was the value of that location placeholder. So now we want to really step back and we want to start developing this skill. So we want to see how easy it is to build skills for this personal assistant. So I'll exit out of here and we'll go to my other screen where you can see that I have a terminal. In this terminal, I'm going to be using a few Node.js packages. So I'll also be using Yarn instead of NPM. So Yarn was released by Facebook recently. It is supposed to be a better version of NPM, but I'm still testing it out. You can still use NPM if you wish. That's totally up to you. But I do have Node.js installed, I have TypeScript installed, and I have Mocha and Typings installed. So Mocha is for our unit tests, and Typings is for our type definitions. So the first thing we want to do is let's go ahead and initialize a new package.json file. Pretty much the core part of every Node.js application. So we're going to say yarn init, and we're going to go ahead and answer the questions that it presents us with. I'm going to use the default for every single one of these questions. Whoops. As I can see, I'm on my desktop right now, so I probably want to delete this and go further in. So I want to make a directory. Make directory, let's call it my project, and navigate into it. And let's do that same command again, yarn init. And I'm going to cycle through these questions. So it now created a package.json file inside of that directory. Now we need to import our dependencies that we're going to be using inside of this project. So we're going to say yarn add, and we're going to say Alexa SDK. So that added the SDK. The next thing that we want to do is we want to add the testing module, so that way we can test this application offline. So we can test it with Lambda online in the cloud, but for simplicity, I found that testing offline is a lot easier. So we're going to say yarn add AWS Lambda mock context. And that went ahead and it added the mock context. This was not developed by Amazon. This was developed by a third party. All right. So the Alexa SDK that we downloaded, it's JavaScript. So we need to get the type definitions in order to use TypeScript. So using Typings, which I assume you've already installed, you would do Typings and then you would say install dt tilde, and you would say Alexa SDK --save --global. Perfect. All right, so we should at this point have all of our necessary dependencies. So we can start really creating our project structure. So right now we just have the essentials that we just imported, but we need to create actual development files. So we want to start by saying, let's go ahead and make directory and create a source directory. We also want to make directory and create a test directory. Inside of the source directory, we're going to create a file called index.ts. And then inside of the test directory, we're going to create a file called modernintent.js. And I'm using a JavaScript file for the testing file because although it is possible, I've done it many times to create tests using TypeScript, it really isn't easy. It takes a little more work because you have to get a few more type definitions, things like that. So I feel like it'd probably be best if we left this test file as a JavaScript file and did all of our skill design inside of a TypeScript file. So what we want to do is just create that modern intent file. It can be named whatever you want. And let's go ahead and clear our terminal right now. The final thing that we can do is before we start developing is we want to initialize a TypeScript project. So we can say tsc --init, and this is with TypeScript installed. And this will create a tsconfig file, allowing us to compile our TypeScript files, or if our editor of choice has plugins available, automatically compile upon save, which mine does. So I'm going to open up my project with Atom. and we can see where we left off here. Let's go ahead and close off some of these. I'm going to start by going into my index.ts file. So inside of the index.ts file, let me zoom in. We're going to first import the Alexa SDK that we downloaded. So we're going to say import star as Alexa from Alexa SDK. All right, so with the SDK imported, now we can worry about creating a TypeScript class. So we're going to say export class handler. And this is like any other kind of class that you would find in another object-oriented programming language. I like to compare TypeScript a lot to Java, but TypeScript is just a superset to JavaScript. It makes things more typed, and I personally find it easier to maintain and makes cleaner code as well. So what we want to do is we want to say constructor. And inside of our constructor, we have a few things that we want to import. So we want to import an event, and this is going to be of type alexa.request body. We want to have a context, which is going to be of type alexa.context, and we want to have a callback, which is going to be of type function. Now this is what Alexa, this is what is passed in. So when you'll do your voice command against Alexa. Alexa will call your Lambda functions, and Lambda will execute this constructor. So what we want to do now is let's go ahead and start populating this constructor. So let's go ahead and say let Alexa equals Alexa.handler, and we're going to say event, and we're going to say context. So this is part of the Alexa SDK. So the next thing we want to do is, although this is kind of, we're cheating on this one a little bit. You might not say it's cheating, but let's say Alexa.appID equals my Alexa ID. So let me explain. So this ID, you would typically get this ID from the Amazon developer dashboard. We're not going to be uploading our skill. We're not going to be using the dashboard, but it's still important that we have an ID because our offline tests will require it. And it's going to be required that we match this ID. The next thing we want to do is create some handlers. So we're going to say let handlers, and this is going to be Alexa.handlers equals, and we're going to leave it blank for now. We're going to continue to bootstrap our application first, but the handlers is where each of our spoken intents reside. So Amazon will say, hey, we're trying to execute this particular intent. It'll lead us to that particular handler, in which point we have a bunch of logic in there. So skipping over that, we're going to say Alexa.register handlers, and we're going to say handlers. We're also going to say Alexa.execute. So as of right now, we are bootstrapped. So before we start creating our handlers, let me go ahead and create another file. This one will be our sample utterances file, just to give us an idea of where we're headed. So we're going to create a few. We're going to create about intent. So every single utterance needs to start with the desired intent. Amazon will go ahead and map that for you. And this is actually not used by our local code. This is used by the Amazon service. So this will actually, this data will actually be uploaded to Amazon. So what we're going to say is who wrote this skill. So if somebody says, hey Alexa, who wrote this skill? The about intent will trigger. We also want to say something like about intent, who is the author of this app? Because you never know what they're going to ask. You have to really anticipate what people are going to start asking you. We're going to create another intent. Let's call this modern intent. And we can say, give me a word. And that's going to be our placeholder. I'm just going to save this for the heck of it. And I won't go ahead and add more of the same modern intent or the same about intent, because I could go on for days with adding hundreds of lines of possibilities. But let's go ahead and say maybe we want to have an intent that has two placeholders. So let's say time intent, and we can say give me the, let's call this date time, because we're going to allow the user to say, is this a date or is this a time? Give me the time, give me the date in location, where location is our other placeholder. So again, we can keep adding more and more intents. It's up to you. But going back into index.js, now what we want to do is we want to start designing the logic for those intents. So let's start with the easiest one, the about intent. And this is a function. And inside the function, we're going to say let self Alexa.handler equals this. And you'll see where this is used in just a second. We're also going to say let output equals, and this could be a string if you want, or you don't have to say it at all. It'll default. Let's say this skill was created by Nick Raboy. All right. Now what we want to do is we want to figure out how we want to emit this phrase back to the user who called it. So we're going to say self.emit, and there's several ways to do this. So you can have Alexa just read that phrase, the output, or you can have Alexa read the phrase and create a notification for it in the Amazon Alexa app, or you can have it do other stuff as well. There's a whole list of different possibilities on the Alexa website. So we're going to say tell with card. And the first thing that we're going to do is we're going to output. So that's what Alexa's going to read. The next thing, since we're telling with a card for the Alexa app, we're going to give it a title, modern web intent, and let's give it an output for the card content. So that is one intent down. So if one of these phrases is triggered, the about intent, Alexa will go ahead and map it to this about intent and read off whatever logic is in here. The next one is going to be a little more complicated. This one, we call it the modern intent. And you can name it whatever you want. It doesn't really matter. Function. And inside of the function, we're going to, of course, say let self Alexa.handler equals this. This time we're going to say let intent request equals, and this was going to be Alexa.intent request self.event.request. And what we're doing here is we're actually going to try to get the values of those placeholders. So we're going to say let value equals, and we're going to say intent request dot intent dot slots. And this is where a slot represents a placeholder. So the first one for this particular modern intent, we're calling it word, and we want to get the value. Just match word with whatever the placeholder is actually named. We also want to say let output equals empty string. And this is where our logic comes into place, and it could be very more complex than what you see here. This is just an example to get you started. Like in my real life example, I actually use the Bay Area Rapid Transit API. So definitely make it much more complex than I'm doing here. So we're going to say if value dot to lowercase equals, let's say ping. So if this word right here, if they say give me a ping, it's going to trigger what's in here. And in this case, it's going to say speed, or we call it output equals I am giving you a pong. Otherwise, let's say that every other word we don't recognize. Let's say output equals, I don't know, YOLO Brolo. Doesn't matter. This is just an example. So if it equals ping, give us a good response. Otherwise, give us some other response. And then, of course, we want to output it. So I'm going to copy this line 12, place it below, and now it's going to output that when this intent triggers. Finally, we have our final one. So I'll just copy and paste for now. And we called it what? Time intent. And we have two slots. We have time value, and then of course we have a date value probably, or we have location value. So this is date time, I think we called it. and that's location. So in this case, we probably want to do some logic in here and do whatever is really necessary. So I'm just going to comment it out. We're not going to add any logic here. I think many of you can probably get the idea of where we're going with that. But it's just a demo that you could have more than one placeholder value. So now our skill is done, but we haven't tested it yet. I mean, our skill doesn't do a whole lot, but that's our goal here. It was just to get it started, get everyone started with it. The next thing we want to do is actually design our testing, so that way we can see and make sure that it works. So I'm going to open up this modern intent, and we're going to start developing our unit, our Mocha Chai tests. So we're going to say var context. Remember, this is a JavaScript file, equals require AWS lambda mock context. This is for testing. We also want to say var expect equals require. And I actually don't think I installed Chai for this project. I think, yeah, so I forgot to install Chai. So let's go into our terminal here. We're going to say yarn add Chai. Just added Chai for us. Dot expect. Finally, we want to say var index equals require source index. And the reason for this is because we're going to use this modern intent.js to test the index file. So that's where our tests become of value. Now we can actually start up our context. So we're going to say var ctx equals context, and we can start defining our testing. So we're going to say describe. We're going to say testing a session with modern intent. So we're only going to test out one of our intents, but you can create as many of these test files as you want, but I'm going to keep it simple. We're going to say function. And the first thing we want to do is we want to set up the possible output results, I guess you can say. So we're going to say var speech response equals null, var speech error equals null. And you can see why we're doing that here. So before we start running our tests, we want to trigger our skill and get a response back. So in order to do that first, we need to use the before function. So we're going to pass in a function here and a callback inside of before, and anything inside of before will happen before our actual tests. So for example, we're going to say index.handler, and I'll explain where that came from in a second. Pass in an empty object and ctx. So index.handler, so we imported the index file, and handler is our class. So this is the constructor. We're passing in an object and the context that was required. We're not passing in the here it is, the callback, but we're passing in the event and we're passing in the context. So going back, before I populate this with actual data, this empty object, let's go ahead and say ctx dot promise, and then we want to say then, and we want to say response, and when we get a response, we're going to say speech response equals response, and we're going to finish this particular before function. So we're going to say done. That's how we exit out of it. That's how we define that we are now done and no longer need to be doing tasks before our tests. If there was an error, we're going to catch it. Equals speech error equals error. And then we're going to say done. All right. So the next thing we want to do is let's write our test. And remember, this is still blank for now. I'll get there. Let's go ahead and write some tests. So we're going to say describe. This is assuming that everything finished now. We're going to say describe, and we're going to name this is the response correct? And we're going to have a few tests inside of here. Function. All right, so the first test that we're going to have, we're going to say should not have an error. because we don't want that speech error to be filled. So we're going to say function, and inside of it we're going to say expect speech error to be null. So if it's not null, then we know that some kind of error happened in our Alexa request, and we need to troubleshoot it. And this is the same kind of stuff that would happen if you were in the cloud as well, not just locally. We also want to have another test. We're going to say IT should have a response. And this one will be same kind of mentality here. We're going to say expect, and we're going to say speech response not to be null. So we don't want that to be null. We're also going to print out the response because I'm going to show you some stuff. So we're going to say console.log speech response and save it. So we have two tests, and that's, I think, good enough for us right now. What we want to do is we want to populate this object. And I'm going to cheat a little bit. So I'm going to open up my terminal again. I'm going to say Atom, and I'm going to say lambda. Oh, I'm not on my desktop. I'm going to say Atom after I navigate backwards. Lambda response. So this is a JSON file that I actually pulled directly from the Lambda AWS Lambda. So this, you can actually use their testing interface, and it can generate this JSON for you. This is the same JSON that we're going to apply in our code, and it'll save me some typing. So I'm going to copy it. I'm going to go back to modern intent, and I'm going to paste it in. We do need to change the application ID because remember, they have to match. So what we're going to say is, I think I called it my Alexa ID, and save it. Our intent is also named something else. We're trying to test the modern intent. And the modern intent has one placeholder parameter called word, so that's good, but we're expecting it to have a value of ping. So with that said, let's go back into our terminal here, and we're going to say, let me go to the right window here. We're going to say Mocha to run it. And as you can see, both of my tests succeeded. So there was no error. The speech error was still null, which it should have been. And we do have a response, and it printed out the response that we got. The test that we wrote does not check the data for validity. We're only checking if the response is valid. So for example, it actually returned what Alexa would now speak. So this SSML, this is what Alexa will speak. I'm giving you a Pong. This card would appear in the Alexa app with the title of Modern Web Intent, and the content being I'm giving you a Pong. But let's go ahead and change this to a value that we're not checking for, ping 1. I'm going to save it, go back into my terminal here, and run Mocha again. This time, of course, it's still valid. Our test passed because we're only checking for response structure, but the value is different. So it didn't recognize ping, so it says YOLO Brolo, exactly how it should. So you can add plenty more tests, but this JSON data is the data that Alexa and AWS Lambda will use. So it's a good start to give you a good idea on how things are done. And in reality, at this point, what you'll do is you'll go to the Amazon Alexa developer dashboard. It will have you upload everything. Well, first you'd upload it to Lambda. You would upload the JavaScript file. It doesn't care about TS, but because we've compiled it into JavaScript, we're going to upload that along with the node modules. It'll tell you everything that it expects. And then inside of the Alexa dashboard, you would link it up by ID, and you would be able to further test it, which would be the same test that we essentially just did. Or you can even test it on your Alexa device as well. So it really wasn't that hard. We used a mixture of things: TypeScript, JavaScript, Node.js, and Alexa is really cool. Voice assistants are growing in popularity. I definitely recommend checking them out. This is my shameless plug, so if you want to follow me, you can find me on Twitter. I'm very responsive. It's at NRaboy. I also have my GitHub and then my personal blog with plenty of tutorials.